Hello everyone and welcome back. In today's video we have another fun limit question. In this video we're going to be taking a look at the limit as x approaches infinity of x minus x squared times the natural log of 1 plus x divided by x. And so at this moment I encourage you to pause the video, think about how you might go about solving this problem, see if you can come up with a different solution than me. And if you do, then I encourage you to share it down in the comments below with the rest of us. Maybe it's more efficient than what I have done here. But yeah, hopefully you've had a go. Now let's take a look at my solution and see how to solve this one. Okay, to start this problem, the first thing we should do is rewrite the argument of the natural logarithm. We should break this apart, divide each term by x instead. So we get this expression over here, 1 over x plus 1. And now what we want to do is sort of get rid of this 1 plus x. That's what's making things complicated. Maybe we can do a substitution, because then what that's going to do is make fractions on the outside. And that's going to be much better because then we can combine this into one big fraction and we might get an indeterminate form of like 0 over 0 or infinity over infinity, and that is something we can tackle. And so as we just discussed, we're going to try that out. We're going to let t be this 1 over x expression, and then we have to change the entire limit. So these x's can just be replaced with x equals 1 over t if you just rearrange this equation. And what about the limit? Well, as x approaches infinity, then what does the graph of this look like? This is just the hyperbola or the reciprocal function. As you approach infinity, it's going to approach 0. In particular, it's going to approach 0 from above. And so that's what we can say. We can just replace the limit as t approaches 0 from the positive side. Okay, so now doing the substitution, we replace the 1 over x with just a t. We replace the x's over here with 1 over t. And we replace the limit as x approaches infinity with t approaching 0 from the right-hand side. So now this is working quite to plan because the natural logarithm's argument has become much simpler and we have the fractions on the outside. And so how about we get common denominators and combine this into one big fraction? So to get common denominators, we need to multiply by t, and we'll get this expression over here, t minus the natural log of t plus 1 over t squared. And so now, as t approaches 0 from the right-hand side, this will approach 0. This will approach 1, but natural log of 1 is just 0. So 0 minus 0 is 0. That is, the numerator approaches 0. And clearly, the denominator is also approaching 0. So we have an indeterminate form of 0 over 0. Now we'll apply L'Hopital's rule and differentiate the top and bottom separately. So the derivative of the top, well, the derivative of t is just 1. Now, the derivative of the natural logarithm is 1 over the input. In this case, the input is t plus 1. And then by the chain rule, you have to multiply by the derivative of the inside. Well, that's just 1. And the derivative of the bottom, just by simple application of the power rule, gives you 2t. Next, let's go on the side and try to simplify this complex fraction and see what kind of resulting fraction we get. Okay, so here is the fraction that we just had, and let's try to simplify it. The first thing we're going to do is we're going to take this 1 over 1 and rewrite it as t plus 1 over t plus 1. The reason for that is because I want to get common denominators so that I can combine this fraction. Also, at the same time, you can think of this 2t as dividing by 1. So you're taking two fractions and dividing them. Well, if you're dividing by a fraction, then you can just multiply by the flip, right? 1 over 2t. Great. And so now let's simplify this. The common denominator is just t plus 1. On the top, the plus 1 and minus 1 will cancel out. And so you just get t times 1 from here. And on the bottom, you get this 2t times one of these. So 2t and t plus 1. This way, the t's on the top and bottom cancel, and you get this very nice, simple looking expression. And so now let's go back to our work from before and sub this over there. Okay, so we stopped over here and we went to the side and we found out that this simplifies to this very nice looking expression. And this is no longer indeterminate. In fact, we can just evaluate the limit by direct substitution. You plug in 0 over here and you get 1 over 2, 0 plus 1. And that gives us a final answer of 1/2. And so there we go. We found the answer to our limit problem. It turns out it's actually just 1/2. And that brings us to the end of today's video, in which we tackled this somewhat scary looking limit question. And the answer was very simple. It was just 1/2. It required like a nice substitution and then we had indeterminate form 0 over 0. We used L'Hopital's rule and some simplifications after that to get our answer. So very nice. Hopefully you enjoyed that, and I'll see you next time. Thanks for watching. If you enjoyed this video or found it helpful, I would really appreciate it if you could like the video and subscribe for more content. And if you have any questions or thoughts, feel free to leave a comment down below. I would love to hear from you.